Combustion can be broken down into several different steps or phases. Understanding these phases will help to understand the basics of fire behavior, or how fire moves and spreads and how much energy or heat it puts out. As we watch this fire burn, we can see the four phases of combustion. Number 1, pre-ignition. Number 2, ignition. Number 3, combustion. Number 4, extinction. Pre-ignition contains two steps: dehydration and pyrolysis. During dehydration, the water in the burnable fuel, the unburned matchstick here, is driven out through pilot heat, or an initial source of heat like a match. Water changes from a liquid to a gas at 212 degrees Fahrenheit. However, fuel temperatures, like the wood matchstick, need to be around 600 degrees Fahrenheit to ignite. Water has a higher capacity to absorb heat than the wood, so until water is driven out of the fuel, the temperature of the fuel will not rise to a point where it can be ignited. The more water in the fuel, the longer the dehydration stage will be and the more pilot source heat needed. In later videos in this series, you will learn about live and dead fuel moistures, which directly affect fire behavior due to the dehydration stage of pyrolysis. Once the water is all burned off and the temperature of the fuel rises, pyrolysis begins. This means the ash compounds of the fuel are degraded and broken down. This produces volatiles, tar, char, and ash. There are two pathways for the pyrolysis of cellulose, which is one of the most prevalent components in wood. Lower heat creates char, which coats the exterior of the fuel. Higher heat leads to flammable volatiles and tar that form a gas cloud above the fuel. Different plants have different chemical components that break down in different ways at different speeds. This can lead to distinct fire behavior and emissions. Here you're looking at saw palmetto burning. The oils and waxes in this highly flammable plant start to be released by the pilot heat, creating a gas cloud. This is why palmetto can ignite even at very high fuel moisture contents. The next phase is ignition. Fuel will be charred or scorched until the pilot heat ignites the gas cloud. Once the gas cloud is ignited, you have flames. Ignition marks the turning point from the endothermic, or heat absorbing, and exothermic, or heat emitting, part of the reaction. Before ignition, the fuel is absorbing more heat energy than it is emitting. Once ignition occurs, the fuel is emitting more heat energy than it is absorbing, and it becomes a source of heat to ignite adjacent fuels. There are two pathways for the pyrolysis of cellulose. Higher temperatures lead to flammable volatiles, while lower temperatures generate tar. The combustion of the gas cloud is termed flaming combustion. This can be seen because if you look carefully, the flames don't look attached to the match. The alternative pathway generates a flameless form of combustion termed glowing or smoldering combustion. In glowing combustion, the tar generated in pyrolysis combusts and appears to glow as the combustion zone migrates over the fuel. Heat from the flaming combustion allows fuel to continue to dehydrate and go through pyrolysis. If pyrolysis is fast, lots of gas is produced and flames can be very long. In wildland fires, flame temperatures can reach 1300 to 1800 degrees Fahrenheit. Lower temperatures lead to char, which are solid particles on the fuel, and glowing or smoldering combustion. This happens before the gas cloud ignites and then once all the gases are burned, as seen in the ashes of this campfire. Smoldering combustion is not as hot as flaming combustion, but it burns more slowly. So the residence time, or time soil and plants are exposed to heat, is longer. This can cause heat to penetrate more deeply into the soil and cause more damage to plant tissues buried beneath the surface. In addition, in smoldering combustion, the products of pyrolysis are not completely combusted. Thus, you get more smoke. The final phase of combustion is extinction. This brings us back to the fire fundamentals triangle. If one leg of the triangle is removed, the fire will go out. If there is no additional available fuel, or because the fuel is all consumed, or if the fuel is too wet and there's not enough heat for dehydration to happen, the fire will go out. The latter threshold is referred to as the moisture of extinction. Lastly, If oxygen is cut off from the fire, it will go out. This principle leads us to the way we fight fire: by removing fuel, putting water on the fire, or by removing oxygen by smothering the fire with dirt. Understanding the fire fundamentals triangle, heat transfer, and combustion will allow you to better understand how fire behaves. These concepts dictate how fast a fire moves, the length of its flames, the heat it produces, and how long it burns in one spot. The behavior of a fire further dictates how it will impact things like soil, vegetation, and air quality, which in turn informs decisions on how to manage fire. Thus, these basic concepts of combustion are the building blocks to understanding wildland fire behavior and management.